Hi everyone, my name's Liviana. I'm head of community at Azure Cloud. Welcome to the CASSINI Hackathon Netherlands Omniverse Workshop. So a little explanation about Azure Cloud. We are on a mission to accelerate green AI to protect our planet's future by building the most sustainable, high-performance compute. As we all know, AI can solve many climate change related issues. However, the more data we use, and the more compute that is required to solve these problems, we're only contributing more to environmental damage. At Azure Cloud, we are combining cutting-edge data center and construction industry solutions to create powerful, secure, and sustainable compute. Today's workshop is brought to you by our hackathon partner, NVIDIA. Vincent, the Senior Product Marketing Manager of Omniverse, will be giving a presentation. For those who have questions about the usage of Omniverse, the solution architect, Chris, will be available to answer questions on Discord. So please feel free to ask your questions on there.
Okay, now let's dig into the Omniverse platform. What is it? What does it do? Why did we make it? So NVIDIA makes a lot of cool technologies, from ray tracing to hair to flow and PhysX and blast and VR. All of these SDKs we make available to developers. All of these developers would start integrating these SDKs. It's a lot of SDKs to integrate, and then every version of their product and our product would often require a reintegration. So that's a lot of churn for getting all these technologies in. And then you multiply that by every new technology that we make, and it becomes very, very heavy to get all of those technologies into all of these products. So we created Omniverse to be sort of a hub. And as a hub, we can integrate all of our technologies inside it, and then all of the applications just have to link to one product, to Omniverse. And by linking to that one platform, they get access to all of those technologies with one simple integration. Sounds like magic? Well, it feels like magic too once you start trying it. So there's a few things that really needed to happen for this to work. We really needed to create a new foundation. So we needed all of the top industry products to be able to communicate together and to our Omniverse technologies. And so we created connectors to create those links, but we also needed to have a common language. We had to have a common file format to work on. So we selected the Pixar USD. Pixar's USD format was built entirely around collaboration. The whole idea is to allow multiple people to work on portions of a scene and move things around. One person could move something, someone else could move the same thing, and it really only transmits deltas. It transmits that little piece of information. If you've ever tried collaborating with someone on a 3D file, it usually means working on something, saving your file, sending them a huge file, they open it up, they do some work, they send it back to you. It's very difficult to merge in changes that one person might have done. If two people were working on the same object, you have to pick one. You can't very easily merge those. There's a lot of issues that come with a standard pipeline. USD makes away with all of that. The format itself supports deltas, it supports layering, it's perfect as a foundation for collaboration. So we took the USD format, but then we still had to tackle the problem of materials. There's many types of material definitions. Luckily, physically based materials have a lot in common. No matter which format you go to, they have a lot of settings that are the same. An index of reflection or refraction. All of these settings are physically based, therefore they have a true value, therefore that value is the same. Doesn't matter which format you use. So getting the materials to be compatible is not as difficult because they're already physically based and they have a lot in common. So we picked the MDL format, which we've created, but we've also open sourced. So we wanted to have USD, which is open source, and a material, which is open source, and also our physics technologies, PhysX, which is also open source. So by having a fully open source file format that handles geometry, textures, materials, physical values, and eventually all sorts of other metadata that we might want to bring through that pipeline, we now have a really strong foundation to build on and to collaborate. So open standards are at the foundation of Omniverse. We have an open format with USD, MDL, PhysX, and other technologies soon to come that is open source, that gives us that foundation to be able to share between all the different applications. Okay, so now what do we do with this foundation? Well, we build things on top of it. So let's take a look at that. So Omniverse is really, you can think of it as 5 pillars. It can get more complex, and we'll dig into that. But there's 5 main pillars. There's Nucleus. Nucleus is the file server. It's where you store your USD files, your universal files, in a server to share between different people. This allows us to do live linking and syncing between different applications and different people. So Nucleus is the center of your sharing experience. Then we have Connect. Connect is a whole bunch of plugins for applications to be able to connect to Nucleus. So there's plugins for all the popular tools. Some third-party tools just have connectors built in, natively built in to connect to a Nucleus server. And you can have multiple Nucleus servers as well. So you have Nucleus server, you have an application with a plugin, a connector plugin, to create this bridge, this live link, so that if I move an object here, this other person sees it move as well. Doesn't matter which application we're in. So by live syncing between our differently connected applications, we're able to enable the highest level of collaboration. So these are really part of the plumbing of Omniverse. Then you have Kit. Kit is our application building toolkit. So Kit is a whole framework with all sorts of different components, and we'll go through a few of them today, that you can use to build your own application. And an application doesn't have to have a GUI. It could even be a microservice. It could be all sorts of different things, and we'll cover a few of those. So Kit is how you build apps, and you build services, and you build new functionality into this Omniverse. And we also have, inside Kit, we have access to a whole bunch of simulation technologies, like PhysX and Blast and Flow, and we'll go through a few of those. Those are actually extensions, and Kit has a few extensions by default. You can activate more extensions, and you can download more extensions, you can create extensions. So the whole world of plugins is covered through extensions for Kit or other Omniverse applications. So we have a bunch of simulation ones, and we'll go through a few of them. And we have the RTX Renderer. The RTX Renderer is also a really big part of why there's a lot of attraction towards Omniverse. A lot of renderers and ray tracers are limited to 1 or 2 GPUs interactively when you're trying to work on it and get that real-time feedback. So RTX Render was built from scratch around a multi-GPU environment. So you can throw more GPUs at it so that you can handle more geometry and faster render times. So it is a highly, highly scalable path tracing renderer. We'll get into that one too. Okay, now let's dig into what's under the hood. So here we have our 5 pillars. We have Nucleus, we have Connect, we have Kit, Simulation, and RTX Renderer. But let's go even deeper. Let's take a look at the SDKs that are powering this. So we have graphics SDKs. We have our RTX ray tracing technologies, rasterization, a lot of those shader technologies you saw earlier in the SMs, MDL for our materials. We have Cloud XR, which is for streaming, VR or AR. And we have our Pixar USD. Then if we go into our compute stack, we have CUDA, obviously, a lot of what powers most of the things we do here at NVIDIA. We have PhysX, we have Flow, we have Blast, and then we have an AI stack. We have audio to face, we have Kowlin for doing 3D deep learning. We have AI denoisers, we have DLSS, we have Jarvis, we have a whole slew of extra technologies that are coming in here. So this stack of technologies is increasing every day, and this is all the technology you can tap into by connecting to Omniverse instead of having to go and integrate each one of these SDKs in your application. So making it so much more easy to leverage these technologies. Now, if we go one level deeper, why do we love all these SDKs? Well, it's because we can tap into that RTX GPU. We can really leverage those tensor cores, those CUDA cores, the SMs, and the RT cores. So to really be able to use all the power out of those that hardware, we need all those SDKs, and all of those SDKs are built into that Omniverse platform. Okay, now let's dig even deeper. Let's take a look at Nucleus and Connect. This is the foundation of our collaboration system. It's our servers and the connectivity to those servers. So it all starts with the file format, with USD. It's more than a file format. It's the basis for all of the data that goes through the Omniverse. So USD is really critical for applications to be able to connect to Omniverse. They have to leverage the USD format. They have to support USD in some way. And then by creating a connector, we're able to do live links between the file and the application, making that file, basically bringing it alive and letting it feed and be fed by all the different applications. So USD is the foundation. It's developed by Pixar. It still is today developed by Pixar. And we're partnered with Pixar to make sure that everything we do to this format is blessed by them. We want to make sure that it is part of the standard Pixar file format, that we're not deviating or making a different version of it. So it's very important for us that this stays open source and universal. So USD has this concept of layering, which is really great. It allows different people to be working on different layers. And that way, two people can move the same object. It doesn't matter because everyone's deltas is saved in each layer. So it's really a foundational part of being able to do collaboration. So it originated in M&E for media and entertainment, obviously, since Pixar created it, but it is really very quickly becoming a standard for other verticals. AEC, manufacturing, product design, robotics. It's really a great format for collaboration, and all of those verticals benefit highly from that collaboration. In order to handle materials, since there are so many different standards out there, we kind of turned to our own MDL, which we created a long time ago to help facilitate having a universal material. MDL is not a material shader, it's a definition of a material, and it is renderer agnostic. So it's a physically based definition that can be read and is actually supported by many different renderers and many different applications already. So we open sourced MDL and put it into USD as a schema. So MDL SDK is still available outside of Omniverse, and this allows applications to natively support MDLs. It's basically a renderer independent definition for physically based materials, and it can run on GPU or CPU. And there's also a distiller to simplify very complex materials that wouldn't run in a real-time environment into a real-time ready material. So it's a really great way to define physically based materials. And we also have a massive library of these materials called vMaterials. We have over 2,000 materials, physically based materials, that are actually shipped with Omniverse as well. And these work in many of those DCC applications, as well as any of the Omniverse applications. So we get you kickstarted with a bunch of these materials. Now we also added PhysX. So because PhysX didn't really have there's no universal format for saving physical values. So we open sourced PhysX. PhysX is one of the most popular physics technologies. It's in a lot of games, a lot of 3D applications. So we open sourced that, and we also added that PhysX schema into USD. So we now have a universal way of defining physics, of defining materials, and of defining scenes. And there's other definitions that will come, that will be added to this, like things needed for BIM, building information, in AEC. The format is open source, and it's open to everyone to expand, so it will grow depending on what's needed of it. And that's the whole point for having an open source format as a foundation. Now let's take a look at the benefits of this. So what can we do with this universal format and Nucleus? So Nucleus allows us to live link applications together. Now, this can be great for a single artist, like being able to have Maya open and Unreal Engine and be modeling something while you see it in Unreal Engine, or Photoshop open and be noodling on a texture or substance while you're inside of Unreal and Maya. So having these interconnections between all of these applications is phenomenal. And that's a great benefit that you get with the Nucleus server and the file format in USD. So just Nucleus and USD with none of our other NVIDIA technologies, you have this great new technology that allows you to do live syncing between applications, and that just didn't exist before. Now, it's great for a single user that wants to link their applications together and collaborate with themselves, basically using those different applications. But it's also great for multi-user collaboration. So I can now have work that is distributed worldwide or within an office between different people. If I'm working on something and I need some help on modeling something, my colleague can just load the same file and start modeling it, and I can keep doing my textures while they're modeling, and I could see it live inside of my application. So the ability to live link applications, and even if you weren't live linking, just the ability to have the application you need for the task. I might bring up 3D Studio Max to do solid modeling, and then I might bring up the same scene in Maya to do some animation. And then I might go into Revit to do a building and have tools to do easier windows. So you can really pick any tool at any time, whichever is the best for whatever your task is. So that's also never been there before. The ability to really have a universal scene that you can work on with any application and that anyone can collaborate with as well. So let's take a look at that in action. And I think that's where it really becomes impressive. In this scene, you can see three different users on the left, and then the result of Omniverse Create on the right. And in a normal scenario, someone might be using Unreal Engine, and they might have their Omniverse Create as well, side by side. And so they're building their level, and while they're building their level, they're seeing it ray traced and rendered in Create. And someone might be in Substance, and they might also have their Create on the side, so they can see the full scene while they're working on the material. And then someone might be in Maya modeling that table that you see there, and they might also have their Create. And maybe a customer is also streaming the result of Create on their iPad and reviewing. So the ability of everyone to see what they're working on, even though they're all in their respective applications, having that live feed of everything put together. That's really the power of Omniverse. It's collaboration, it's live sync, it's ease of transferring a file from one application to the other because there's no more transfer, it's the same file. So it really massively changes your pipeline from a very linear pipeline where you have modeling, then texturing, then you might have some scene building and some animation. All of this becomes a web now. It can all happen at the same time. And if you could be on set doing a virtual production and an object gets so close to the scene that it needs more detail, no problem. Bring up Max or Maya and bring up that item and model it while it's live on your wall, right? So that ability is really a magical part of Omniverse. I say magical a lot, but it feels like magic to someone who's been doing visual effects for over 20 years. So we have connectors for all of the popular applications, and more are coming. It really just requires an application to support USD, and because USD is already a very, very common format, it was already supported by many of these applications, so that helped with adoption. And then with the connectors, we're going one step further than having a universal format, but we're creating these live links, these live bridges that allow us to have that interactivity. So you'll just take a look at our website. You'll see a lot of these different partners coming on, and you'll see a new one fairly often. Okay, so now let's go a little deeper into Nucleus. So just to give you a bit more depth on how Nucleus works, Nucleus is a server that you can install. So as a single user, you can install your own Nucleus server on your own machine, and that Nucleus server will keep sync between your different applications. In the illustration here on the bottom left, we have someone that could or could not be, could be doing effects or not. So you could have a standalone server or you could just run server on someone's workstation. So this is a workstation that has the Nucleus server on it, and it's right now being used to sync between the 3 other artists. So this is a group of 4 artists working together, collaborating, and they're all syncing on the Nucleus server that's in that first workstation. So that's one little Nucleus hub. Then you could have another group that have their own Nucleus server. And you could also have a Nucleus server in the cloud. So this could be on a cloud service somewhere, and that's where our storage is for all of our files. And in this case, we have 3 remote users. They may be using their local hardware, or they might be using VMs, or it might be a mix. Maybe they're using a laptop with a GPU by day, and then when they need more power, they use a VM from the cloud that has 4 GPUs attached to it. So you could have remote users that are using a cloud Nucleus. Now these organizations could also connect to it. So I could have a small office that is working on the building, for instance, and they might have all the assets for the furniture. And then I might have another group that's doing landscaping, and they may have all the assets for the trees and the shrubs. So everyone can actually use combined assets from multiple Nucleus servers. So the team 1 here might have all the architectural stuff in their own little server, but they might be pulling the trees from team number 2, that is the landscaping team or company. And they might also be syncing with a cloud service to keep everything in sync with another group. And all of this could be intermixed. So it doesn't matter how many Nucleus servers there are. You can have these references and these links from these different servers, and all of these assets will be cached in your local system. So you're not, and also you're only feeding deltas. So the amount of data that's being transferred when you're moving an object is close to nothing, because it's only the delta information that's needed to move that object at the other end. So you can have a whole spiderweb multitude of Nucleus servers, and have you could have different types of assets coming from different servers, etc. So hopefully this clarifies a little bit the Nucleus server. There can be many. There can be one. You can have one locally. You'll probably find growth in this area. It's kind of like web servers, where there can be multiple web servers out there, many assets everywhere. It doesn't matter. You'll go get the asset wherever it comes from. So we're essentially building sort of an equivalent of the internet, right? What internet is to web browsers. Anyone can go and open a web page and see everything with a standard format. We're able to now have any 3D application load any of these 3D files from different servers, and even mix and match and cobble things together. Okay, so now let's go back into our stack, and let's go up in the stack. So up in the stack, we also have apps. So we already mentioned Kit, which was for building apps. Well, we actually pre-created a whole bunch of apps, and we put them out there. So there's Audio to Face, which is specifically for animating characters. There's Create, which is for kind of multiple uses. Anyone who's doing digital content creation, this can be useful for. It's got PhysX, it's got ray tracing. You can manipulate and assemble scenes in it. There's a whole bunch of things we can do there. We have Kowlin for doing 3D deep learning research. We have Machinima for doing animations, for animating assets and doing cool little videos, or cinematics for games, for instance. And Omniverse View, which is specifically created for AEC, for architecture and engineering. It's made to be very, very simple to bring in a CAD model, put materials on it, do sun studies, ray trace, very, very easy to use. And we have very complex applications like Isaac Sim or Drive Sim. And these are for training robots or training autonomous vehicles. So very complex, powerful products built on top of the Omniverse platform. In fact, that's kind of why Omniverse exists, is we needed something extremely powerful to handle very, very large scenes and very complex tasks like physics and dynamics and an entire autonomous vehicle stack. And that didn't exist. So we built it. We built Omniverse to be able to handle the toughest challenges in 3D. which are the ones we're tackling with robotics and autonomous vehicles. So there's also that layer of extensions, and I did mention this before. These are kind of like plugins. So it's not an app, it's just extra technology that you can activate within any of these applications. So the beauty of Omniverse is that everything is extremely modular, which means that an app is really just a list of loaded modules with a GUI layout. And a lot of these technologies under the hood are extensions like PhysX and Blast and Flow, and there's hundreds of them that ship with the product. So you can mix and match and load whatever extensions you need. Here are a few as an example. There's an extension manager within Omniverse. So you can launch that and go and load tools. This one is the animation USD skeleton deformer. There's a whole bunch of stuff that engineers have put together because they needed it and it wasn't there. So they made a little plugin, little extension. And some of them are a lot more powerful, like PhysX, for instance, where we wrapped an entire SDK and an entire technology in an extension that you can just load inside of the application. So let's dig into Kit. So Kit is our pillar for people who want to create applications. Okay, so what does the stack look like for Kit? So we're going to go digging even deeper. So Omniverse Kit is a framework that has a bunch of technologies. Yet again, there's USD, there's PhysX, and there's new ones like Omni UI, which is for building interfaces. There's Python, which is for scripting. There's Omnigraph for doing flowcharts and graphs that interconnect. There's a Nucleus client. There's RTX ray tracing. So there's a whole bunch of technologies that make up Kit. That's kind of the foundation to build applications. Then we have core extensions. So these are extensions, but they're kind of essential. So we have a content browser so that you can load files. We have mesh tools so that you can move stuff around in the scene. Pretty basic stuff. And texture tools. So those are core extensions that are part of every application. And then we have extensions, which we already saw a few of those. Things like asset, import, export, animation tools, Jarvis. These are things that are additional that are not part of the base Kit. And then we have assemblies. So assemblies are just complex assemblies of all of these different bits. So there's apps, which we just went through. So apps like create and view, those are really just sets of the basic Kit functionality with the core extensions and a specific subset of extensions that we picked for a specific use case. Like View for architecture engineering has the Sun Study tool loaded, whereas in Create, it might not be there by default, but you can always load it. So all of these extensions are there, and you can mix and match whatever you need, wherever you need it. And then there's microservices. And microservices are basically apps that don't have GUIs, or they might have a GUI that lets you pick something. But microservices are basically smaller apps that are usually run as a service. So it could be a format converter, a batch renderer, a thumbnail generator, or all sorts of cool AI technologies like Deep Tag that takes your entire scene and will take every item that's in your scene and render it and make an image out of it, a 2D image, and then run it through an AI to determine what it is. So it automatically tags that object, like adding metadata to it. So there's all sorts of cool things you can do with microservices or apps. So let's take a look at what an app is and how they're put together. Okay, so let's take a look at Create. Create is one of the applications we provide. And it looks like a regular app. It's got a bunch of different GUI elements there, but it's really made up of a whole bunch of components. So instead of being one massive application, it's actually a whole agglomeration of extensions. And the extensions are building blocks for applications. So at a higher level, they're all written in Python, and they assemble the UI and the workflows and the general feature set. When required for performance reasons or to access some of the CPP APIs, lower level C++ plugins can be added to the extensions. And then we can use bindings to connect them with the UI. So there's, it's a very robust system that allows us to create these complex interfaces. There's the RTX viewport extension, And this allows us to create viewports that have the RTX renderer built in, where there's the path tracer, the real-time renderer. We'll see some of those a little bit later. We also have things like the content browser. The content browser itself is made up of smaller components. So we really have an extreme modularity, making it possible to create anything you can think of in terms of an application, layout, and functionality. Now, a lot of these are already there. They're already extensions, and you can just leverage them, and you can create your own. We have a multitude of widgets available in all sorts of shapes and sizes for doing layer controls, materials, scene graphs. There are tons of components available to you. And all of these were created and are part of Kit. So in Kit, you can take all of these different sections, assemble them together into whatever application you can think of. We also have Omni UI. This is how we generate the UI. It's a declarative syntax. It's inspired by Web and Swift UI. It's very, very simple to use. You can see the image on the left, the code on the left is generating the image you see on the right. So it's very, very simple, very small amount of code to create a fairly complex UI. And we also have the scene graph. So Omnigraph, Graph UI allows us to do these very complex trees and organizations. So you can see a flowchart of one of the scenes on the left with animation. We have one with materials. So you have Omnigraph in here to create all sorts of different graphs. And you can also use Omniverse and integrate it into another application. So in this case, you're seeing Create, but it's running inside the viewport of Maya. So you can take components and technologies out of Omniverse and basically integrate them into other applications. So you could link to it out externally, you could feed it inside a viewport, you can do almost anything. So let's take a look at the RTX renderer. The RTX renderer is really one of those key components that really attract people to the platform because there aren't many renderers that can interactively ray trace and path trace with multiple GPUs. Usually multiple GPUs means 2 with real-time environments. In our case, it could be 8, it could be more. So it's based off of the Hydra API. And the Pixar Hydra API is open, and it means that any other Hydra delegate can work within the Omniverse platform. So there are a multitude of renderers already that you can also add into Omniverse applications and render with. So RTX real-time mode is built from the ground up to support significant scene complexity, physically accurate materials, lighting, global illumination, multiple GPUs. RTX real-time is unique in that at its core, it was built for ray tracing. And unlike traditional real-time renderers that are built on rasterization. So ray tracing can support massive amounts of polygons. So it's ideal for really complex scenes, complex virtual worlds, CAD data, and film quality assets. So having a ray tracing based application means we can really scale with very large scenes. And then we have the RTX path trace mode, which is designed around ground truth rendering using path tracing. It's interactive, it supports multiple GPUs, and it's great for the most visually demanding scenes. This is really the crown jewel of the renderer. We also have iRay. iRay is great for physically accurate rendering. It leverages MDL and it does spectral rendering. So if you really need a true simulation of reality, you can use iRay. We also have Storm. Storm was developed by Pixar. It's an OpenGL-based raster renderer. So this doesn't require RTX, and it's great for fast previews on almost any GPU. Okay, now let's talk about materials. So you can use both USD Preview Service and MDL for your materials across all of these renderers. Lighting is also based off Pixar technologies. It's off their Lux lights, and it enables accurate lighting. There's area lights, disk lights, sphere lights, directional lights, dome lights. They're all interoperable across a wide range of creation tools. And then we also have post effects like depth of field, fog, bloom, tone mapping. And again, all of these effects work across multiple renderers as well. Okay, now let's talk about simulation, which is one of our 5 pillars of the Omniverse platform. We've integrated a lot of our great technologies into Omniverse, like PhysX for dynamic simulation, Blast for breaking objects apart, and we have Flow for fluid dynamics. Notice how the tree that's burning in the bottom center there is actually lighting up the other trees around it. Now that's not a fake light source being put there to simulate it. It's actually ray tracing lighting that's emanating from that fluid simulation. So these are great technologies, and they've become even more powerful lately. PhysX is now at 5.0, and the level of precision is incredible. It has been enhanced to be able to do very complex tasks like simulating robotics. So we use our new PhysX 5 to do very complex tasks, like you can see the hand on the right that's moving the block around. That's not animated by hand. That's all done through physics. It's all being simulated. So we need a level of realism that has never been reached before in order to train robots. In order to train a robot to grapple an object and handle it, it has to react the way the object really would. So it really has to be a perfect simulation. So we have our Isaac Sim robotic simulation that allows us to simulate virtual worlds in Omniverse, train the robots, and take that training, put it in the real robot, and let it go. So it's a very, very powerful tool for accelerating the deployment and training of robotics. And autonomous vehicles is a whole other level of world building requirements. We have to create an entirely virtual world that looks real to the vehicle that's learning to drive. So not only do we have to simulate a whole world, we have to put a virtual vehicle in it, and we have to render a virtual world to feed to the virtual vehicle to learn to drive. So it has to be getting the source from all of these virtual sensors. We have to do a virtual LiDAR and feed the virtual LiDAR data from the virtual world into the virtual car so it can learn to drive in the real world. So very, very complex levels of simulation that have to be accurate in order to be able to translate to the real world. So the level of fidelity required for Omniverse was not found anywhere before. So we had to create it, and that's why Omniverse came to be, and that's why we have these great simulation tools and this great foundation for collaboration and tying it all together. And it had to be highly scalable over multiple GPUs, seeing as the complexity of what we're trying to achieve here. Okay, now we're going to go into microservices. So all of these great technologies can be used through the applications that we provide, but you can also use them as microservices. Because we have Nucleus and we have all these connected applications, we can create microservices that also apply to the data that's in Nucleus. So these microservices could be things like format converters, batch renderers, or some type of machine learning training. So we have all these applications that are connected. We have a Nucleus. We have our apps that are connected. And the apps that we create can be used either locally, or they can also be used remotely. So we have Cloud XR to be able to stream those applications to do VR, AR, or even stream right to a web browser. So there's all sorts of different ways to consume the data that's coming out of our Nucleus server through our applications, whether it's microservices or applications. So how do you get started with Omniverse? Well, it's easy. Go to our website and download the Omniverse launcher. During the open beta, it's easy to get, and it includes a whole bunch of applications. There's a launcher for Windows, there's one for Linux, and we even have videos on how to use the launchers on NVIDIA On Demand. Here are a few of the resources we have for you. There's a product page on NVIDIA.com. There's a developer page on developer.nvidia.com. Within the launcher, you'll also find product pages that have at the bottom links to their respective release notes and documentation, and those will take you to our docs.omniverse.nvidia.com, our documentation center. We also have tutorials that are on our NVIDIA On Demand platform, which you can also now find in a Learn tab inside the launcher. We also have our forums, so we invite you to go to the forums if you have any questions. We have a YouTube channel, we have a Twitter channel, and we also have our news. So we have a news panel inside the launcher in which we aggregate all the Omniverse news from our corporate blogs, our developer blogs, and our developer news. So all three of those sources are being aggregated together for you inside of the launcher, making it really easy. So we have a lot of partners that are on board with Omniverse, and this list is growing. It might even be obsolete by the time you see this video. And again, Omniverse gives you this great capability to live link applications together. You can see here Revit on the bottom adding windows in Omniverse that you see at the top right. You have someone in 3ds Max here changing the chairs and tables inside this room. So we have a Revit architect and a 3ds Max artist collaborating on this same scene. And this scene you're seeing inside of Omniverse view, in this case on the bottom left and bottom right, and you're seeing the outside and the inside at the same time. You can have multiple instances rendering different viewpoints at the same time. So the collaboration capabilities and the pipeline shortcuts that you get out of having this capability are just tremendous. Hopefully you'll find that for yourself. We can't wait to see what you do with Omniverse. Go ahead and download the launcher, get started.
So, as I mentioned, if you have any questions, feel free to ask them in Discord. The solution architect, Chris, will be happy to answer your questions prior to the hackathon. However, over the hackathon weekend, you can expect our CTO, Kevin Smith, from Azure Cloud to be available to answer any of your questions about Omniverse or any tools, as well as Christian, the solution architect for NVIDIA. He also specializes in quantum computing, so feel free to ask him any questions not only about AI, but quantum technologies. And finally, Pierre-Antoine will be available for expertise support over on Sunday as he prepares to judge the pitches. He'll be one of our jury members to help select the winning idea that will go onto the central hub and also win the NVIDIA Inception program support. So thank you again, and don't forget to join us at the CASSINI Hackathon and be sure to apply today. Thank you.